Hello, and welcome back to another batch file tutorial from Chin Diamond, or the Winnie Stint. So today I've had a lot of requests, and we are going to be programming with batch to do monster AI, or artificial intelligence. Now, programming artificial intelligence is actually quite simple, because you literally program the monsters to do whatever you want to do. It is that easy. The difficult part, though, here's a catch, is that you have to figure out a way to do it for each monster in a reasonable amount of time and in a reasonable way workflow so that you can see exactly what you're coding there. Monster AI eats up a lot of CPU cycles, especially in Bash, because Bash is not natively a multi-threaded program, or programming language, I should say. There are ways to make it multi-threaded, but I do not know how to do that yet, and that will take some further research on my part. In the meantime, I will be showing you how to implement the beginnings of the A* search algorithm, an algorithm in which the monster will find the shortest path to the player, no matter what obstacle. Okay, so here we have the workflow. This is the beginning of the A*. I have no wall detection yet. That will come later, as I have not actually figured out how to implement it yet in Batch, but this is the bare bones of it. So it uses the Pythagorean theorem as the main part of this code. So for this monster AI, you really only need three major variables: the player position, the monster position, and you'll use those two to find the distance. Use the Pythagorean theorem to find the distance. This is basic Algebra 1 or Algebra 2 math to use the sides of a triangle to find the hypotenuse. Rounding is going to be an issue that we will touch on later, as the native mathematics in Batch are integers, not floating point. And there is a way to do floating point math here, which I will show you. Once you get the distance, for each monster, you have to do this code up here. Once you get the distance, you can do whatever you want, and then you will finally initiate the player's turn. So here in CMD Rogue, there is quite a lot of code. Where is it? So here in CMD Rogue, right here is where I've implemented the Pythagorean theorem. Now, the Pythagorean theorem here is not actually my code. I had to find it online and look it up because I had no idea how to do floating point decimal calculations in Batch. I will try to search online and find the same code again, but if I cannot, well, here it is. Just know it is not mine. All in all, it looks fairly simple. Just an if statement inside of a for loop here. The for loop goes from the square, which you calculate, which is pretty straightforward, and just decrements by 1 until it reaches 1. And it does this. Actually, it looks like it's fairly simple, because all it does is just multiply a number by a number until just multiplies the number by the same number until it reaches whatever number it was inputted. So basically it's just a brute force method of finding a square root, but it works. It is not fast, but it works. I cut out the decimal part of this code, but the decimal part of the code was actually not that much different than this. It was literally just this, but having everything shifted down a bit. I deleted it. I do not have the original code because the floating point is really a string in Batch, and that would not work in these calculations. In CMD Rogue, once I have the distance between the player and the monster, the code goes as follows. If the monster, or here C denotes the monster position, that's digit, if the distance is less than or equal to 6, do this code. Now, if it is less than 6 but greater than 3, then the monster will have a 50% chance of moving towards you. Otherwise, it will just do a random walk. Now if the monster is less than 3 tiles away from you, it will go directly towards you. And then, and only then, will it go into the combat, which I guess could pose a bug somewhere that you could exploit. I've never found it yet, but that actually looks like a bug just waiting to happen. This is the random movement. This could actually be, I could actually put this into a much more compact way, but I haven't done it. If you notice, I have the monster being able to go in 8 directions. Well, 9 really, if you count staying still. And then once I get the coordinates, I map the monster onto the map. Now this part is the collision detection, which I fixed in the other video. I still need to figure out how to generate the monsters correctly inside walls in the room generation, but that's beside the point. Here we can see the Pythagorean theorem code cut out of CMD Rogue so that I can show you just exactly how simple this is. It's literally just a small for loop that does basically a brute force attack to figure out what square root of what number it is you're trying to find. And once it finds that number, it does some formatting, and then it pipes it out. One small note, I don't think I've ever actually told you guys exactly how to find the number, the c-squared number. It is actually very simple. Here, I'll give you the pseudocode here. Pseudo code. Basically, there's a set a variable equals here squared plus squared. For batch, I would have no spaces, and here would be the delta x, and this here would be delta y. Delta just denoting difference in. Up here I have it hard coded out because I didn't really realize that I could actually use the caret in this sort of math. I always use this caret in XOR functions. I never knew that it could actually be used in exponents. Now that we know how to use Pythagorean theorem code in our batch program, let's do it. So it turns out that I realized 2 things while writing the code. One is that I was basically rewriting the entirety of CMD Rogue. So instead of rewriting the code, I will show you exactly what and where the monster AI is in the code and go from there. Number 2, I couldn't really finish recording the rest of the video in one shot because I got a RAM error, most likely from me overclocking my RAM a bit too much and not testing its full stability. Oh well. Well, here we go. So as you can see, I got sort of far into the test code for you guys. It doesn't work. I ran it and I got some errors and whatnot. It doesn't work the way you want it to. But aside from that, I'll show you exactly what it does, because CMD Rogue still works, and I copied a lot of it over from CMD Rogue because I didn't want to rewrite the entire thing. That's probably where a lot of the errors came from. So first of all, we have our map, our template map, which is pretty easy to do. I've shown you guys how to do that in previous videos. Same with the drawing style, with the drawing frame. In fact, this is what CMD Rogue was for the greater part of 2 years. It was only just you and one monster, not multiple monsters. From there, you press the key, which is detected by kbd.exe, which is actually a keyboard interrupt deal. It does not detect every single key press you do. It just detects all the keys that are interruptible. Control C, coincidentally, is a universal keyboard interrupt, which is why it is used to close out of so many programs on so many different platforms. From there, we do wall checking. which is actually pretty. I actually don't like this style of wall checking or tile checking anymore. I actually like this style down here better. I will revisit the whole collision detection video and make a new one based on this line right here at some point in the future. Please like this video, please subscribe. That shows me that you guys actually learn from these videos and that you want to see more. Alright, from there, basically it is exactly just this, the Pythagorean theorem code, copied in over to find the distance between, by using the x and y difference between the monster and you, okay? But because it's squared, it doesn't matter which one is subtracted first. It truly doesn't. In any case, it returns the digit, or it returns the value of the distance. And in this code, this is the same code copied over from CMD Rogue, but I just have it copied over so it's a bit easier to understand. If the distance is less than 6 tiles, but still greater than 3 tiles, the monster has a 50% chance to move towards you. If it does not, then it goes to here, random move. Which actually I have no idea how it goes there. It just skips over it. Yes. Then it does this. I have it set up in such a way that it is completely linear. That doesn't loop back. It avoids looping back as much as it can. However, if it is less than 3, then it goes towards you. The way to find out which way to go is just simple math. If it's greater than, or if its position is greater than yours or less than yours, in the x or y, just move toward or away from. In this part, and only this part, because it is less than 3, the monster will enter combat mode if it is right up against you, or if it moves onto your tile. This looks like a bug just waiting to happen because it looks like you can exploit this line of code right here in the gameplay. I have not been able to do it, and in fact I just noticed that. Anyway, down here the monster gets its coordinates set very similarly to what the player's is. In fact, I guess I could delete this stuff and it'll still work. However, I'm not really. Nah, actually I lied. That won't work because of this. Anyway, then it goes to monster combat, but I really didn't feel like coding that because if I did, I'd be making an entirely new roguelike, and that's just a pain. So all in all, that is what this code does. Unfortunately, I do not have a working demo. I will revisit this video again, so it's not so rushed, and I'll have a working demo and a bit cleaner code, see if I can't shorten things up. In the meantime, let's just see. What's weird is that I actually just found a weird bug that I don't know if you guys ever encountered it, but I actually just opened this game, and from the title screen, when I hit enter, it just kind of froze, or it said loading game, and that was it. Yeah, it didn't. It just stopped and froze. So there are 3 monsters here, and I'm moving quite fast, and they are all greater than 6 tiles away from me, so they are moving on a random walk. Please note that batch files are a single threaded application, unless you make them not, which is a whole topic for a different day and something I need to look into. So the speed at which it will run heavily depends on how many background processors you have and how fast your CPU cores are. My rig has a AMD FX 9590 overclocked to 4.8 gigahertz. I'm planning on clocking it up to 5 gigahertz because I have the cooling available. In fact, if you just listen to the ambience, you hear that? This microphone is 1.5 feet away from my computer, and that's whatever I hear for the CPU cooling. And the CPU right now is around 32 degrees Celsius with this Corsair cooler on. It is a dual fan water cooler, but yeah, it's extremely quite cooler, and it keeps the CPU very cool during gaming. If I crank up the profile to performance, I can get it around 6 degrees Celsius while it's still overclocked to 4.8 gigahertz. So yes, I do have 3 monsters running, and that's why it looks very good for what it is. And keep in mind that I'm also recording this on screen, so if I wasn't screen recording, this could be extremely fast. So here, I'll show you. Alright, if you notice that there's a monster right here, he's for some reason, that code doesn't work in the generation. Also, for some reason, you get random flickers. That's not anything but just the way batch works. Let's see if I can't find a good example here. There we go. So right now that monster is more than 6 tiles away from me. So if I just wait, he has a 50%. He has a random walk. I have to get within 6, but still less or greater than 3. He has a 50% chance of moving toward me. Now if I get within 3 like that, he has a 50% chance of moving toward me, and he's right up next to me, so of course he's going to go right, he's going to follow me around. There, that's a bug that I was looking at how to exploit. Anyway, that's basically how Monster AI works. There's not much to it other than that this processor makes the start menu extremely smooth. Oh man, look how smooth that is. Anyway, yeah, that's really how it works. I will revisit this video again later when I have some more time. But until then, have fun programming. This has been Jin Diamond.